Okay, let's look at this question from the grade 11 November 2017 chemistry paper. It's based on intermolecular forces. So it says, consider the list of 6 substances with their formulae and boiling points in the table below. So we've got water, ethanol, bromine, iodine, ammonia, and phosphine. So phosphine we don't see all that often. It's a phosphorus atom bonded to 3 hydrogen atoms, but nitrogen and phosphorus are on top of each other in the periodic table. If you go have a look, you'll see they're on top of each other. So we can expect ammonia and phosphine to be very similar in structure and all the rest of it, because nitrogen and phosphorus in the same group. So the first thing we want to do here is organize these molecules so that we know who's got the highest melting and boiling point. Okay, so if we have a look here, this one's going to be phosphine. It's negative 87. Ammonia is negative 33. Then we come over to the positive side. Bromine is over here. Then ethanol, I'm just going to write eth here. Ethanol is 78, because what's this? This is 58. I'm just abbreviating it because of space, yes? 58, 78, 87, 33. Okay, and this is 0. Okay, so bromine was 58. Ethanol is 78. Water is 100 over here. Okay, and then way above water is iodine. Okay, so this is a high boiling point on this end, and this is a low boiling point. And in fact, we know this one is solid at room temperature and this one is liquid at room temperature. So fairly obviously, if room temperature is somewhere over here, okay, all of these are going to be gases. All of this going this way is going to be a gas at room temperature. Okay, so it says to explain why ethanol is soluble in water, refer to the relative strength of the intermolecular forces in ethanol and water. Now look at how ethanol is written, CH3, CH2OH. If we were to draw ethanol, okay, we would draw 1 carbon with 3 hydrogens bonded off it. That's the CH3. And it's bonded to another carbon with 2 hydrogens, and then finally it's bonded to, it's a carbon bonded to 2 hydrogens, it's bonded to an O, which is in turn bonded to an H. So there's 2 carbons, and on the end here is an OH group. So now if we look at ethanol and we look at water, can you see they both have oxygen bonded to hydrogen? And if we look at the electronegativity of hydrogen and oxygen, and I don't have oxygen here with its electronegativity, never mind, just go look it up. You will see that the delta electronegativity of the oxygen-hydrogen bond, okay, this makes it a polar bond. So if we've got an oxygen-hydrogen bond, the bond itself is polar, and the moment we have a polar bond, the oxygen becomes slightly positive, the hydrogen becomes slightly negative, and the same thing will happen here. This oxygen will be slightly negative, this hydrogen will be slightly positive on the ethanol. So if we want to answer 3.1, we need to say that both water and ethanol have similar kinds of intermolecular forces. Okay, so please write out the whole intermolecular force. I don't have space. Both water and ethanol have similar intermolecular forces. They both have hydrogen bonding. Okay, if you didn't want to say hydrogen bonding, you know that hydrogen bonding is a special form of dipole-dipole. So you could say or dipole forces. I don't think they can mark you wrong, because hydrogen bonding is a special kind of dipole-dipole force. And remember, we have that chemistry law, like dissolves like, but we can write here that substances with similar intermolecular forces will dissolve each other. Okay, so basically the the strength of the force is basically the same, so they are going to dissolve each other. And I really don't like this color pen. Let's go back to a different color pen. Okay, then it says to explain why the boiling point of iodine is higher than that of bromine. Now remember here, iodine and bromine, it's I2 and Br2, okay? They are both diatomic molecules. They both share one electron. It's exactly the same kind of covalent molecule. And they are covalent molecules. They are not polar molecules. So they only have the weakest kind of forces. They both, you need to say they both have induced dipole or London forces. Okay. These are weak forces of attraction, but iodine is larger than bromine. Okay. And remember that the larger iodine is larger than bromine, and remember that the larger the molecule or the larger its surface area, the stronger the intermolecular force. So iodine is larger than bromine and so has stronger intermolecular forces, okay, which require more energy to overcome. Okay, I'm shorthanding here, which need more. Please don't shorthand in your answer. They need more energy to overcome, and so the boiling point is higher. And so the boiling point of iodine is higher. Okay, so you must name both kind of forces, and then you must say why is one stronger than the other. Then you must say more energy is needed to overcome them, and so the boiling point of iodine is higher than that of bromine. Now it says to you, explain why phosphine will evaporate faster than ammonia by referring to the types of intermolecular forces present in each substance. Now have a look here. Have a look here. Here is the electronegativity of hydrogen. Here is the electronegativity of phosphorus. What do you notice? What is the change in electronegativity of the phosphorus-hydrogen bond? 2,1 minus 2,1 is 0. This bond is not polar, okay? Whereas what is the difference between nitrogen and hydrogen? The electronegativity difference between nitrogen and hydrogen is 3 plays 2,1 is 0,9. So ammonia, we need to be writing all of this nonsense. We need to name the bonds. Ammonia has hydrogen bonding, okay, but phosphine only has those boring induced dipole forces, okay, because there's no delta electronegativity to make a polar bond. But phosphine has induced dipole intermolecular forces. Now state hydrogen bonding is stronger, so the ammonia molecules need more energy to become a gas or to separate to overcome the intermolecular forces. And you can write this either way. You can say ammonia needs more energy or phosphine needs less energy, okay, to overcome the intermolecular forces, and therefore as a result phosphine has the phosphine evaporates faster, because remember evaporation is going into the gaseous state. You can only go into the gaseous state if you overcome your intermolecular forces. Now it says to you, water, ethanol and bromine are all liquids at room temperature. Which one will have the highest vapor pressure? So remember, vapor pressure is inversely proportional to boiling point, okay? So if we want the high vapor pressure, we want the low boiling point. So which one's got the lowest boiling point of what we must pick: water, ethanol, and bromine. We need to pick. Bromine is going to have the highest vapor pressure because it's got the lowest boiling point. So here we go back here and we discuss the intermolecular forces. I don't have space to write it down, so just listen carefully. So if we see here, bromine has got induced dipole or London forces. Ethanol has has dipole-dipole or hydrogen bonding, and water has hydrogen bonding. The hydrogen bonding is strongest in the water because it has the highest boiling point, and bromine has the weakest forces, as with the London forces, and that means it has the lowest boiling point, which means it has the highest vapor pressure, because boiling point is inversely proportional to vapor pressure, because a low boiling point comes from weak intermolecular forces.